Hi, in this video we're going to talk about auto shrink, one of the database options available in Microsoft SQL Server. Now, I was wondering if I should even bother creating this video because it's kind of understood that you shouldn't be using auto shrink inside Microsoft SQL Server. And generally, even shrinking the database is discouraged, mainly because of the impact it has on performance. But I feel most people are not usually aware of how shrink causes these performance issues. So this video is going to focus more about why shrinking in general is bad, and as a caveat to that, or as a side to that, we'll talk about auto shrink per se. Now, as you can see here, the auto shrink database option is by default set to false, and that's a good thing because for the most part we don't want the database to shrink automatically. Now, before we get into details, let's just look at this query here. So what we have is I've got a query that tells me the size of the database. As you can see here, right now the size is about 2 GB in the data file and 1.4 GB in the LDF. And then I've got a script that inserts some dummy data into a table, followed by checking the size of the database. Now, there will obviously be some amount of free space, so the values between the first and the third query usually matches, but occasionally there might be auto growth, at which point the size will change. In addition to that, I'm looking at the fragmentation on the clustered index of the table. So you'll see that I've got a table called dummy and I've got a clustered ID column here. And then I'm randomly deleting some data, which kind of just randomized by using the new ID. And then checking the fragmentation in the table or the index. After which I'll be checking the size. Let's go ahead and just run this query a couple of times and see what things look like. So as you can see right now, the MDF and LDF file hasn't auto grown. There's some free space available, so it was able to insert some data into the table. In addition, you'll see that my clustered index fragmentation also hasn't really changed much after the delete operation. And you'll see that right now the database which I'm running this on, which is my data, doesn't have anything preventing the shrink operation per se. You'll also see I've got another database called DB options, inside which right now I'm not able to shrink because there's an active transaction that is running. In fact, I think that's done, so maybe the next time I run it, it should be that. But let's see what happens. So I'm going to run this again. And as you can see here, right now the size of everything remains the same. The fragmentation of the index looks fairly good, in spite of the fact that we're randomly deleting data from different parts of the table. I'm just going to run this a few more times just so that we have some baseline sort of figure out how things are going. Now at this point, typically what happens is you finish some ETL operation, which is what I'm trying to kind of simulate over here, and you'll see that my MDF and LDF files have grown to some extent. And assuming that I have run out of disk space, the next thing I want to do is reclaim that space back to the operating system, which is why we typically do shrinking of the database. Now, the fact is that you can always go ahead and shrink the log file easily because the log file is a sequential write-heavy file, and therefore there is no concept of fragmentation that happens in the log file. But when you look at the data file, there is fragmentation because what happens is we've deleted data and there are unallocated pages in different parts of the file, and shrinking works by taking the last page and then pushing it closer to the beginning of the file, so that all the free space is accumulated at the end of the file and then just shifted back to the OS. So there is some amount of rearrangement that goes on, which causes the fragmentation. So to prove that, what we're going to do now is I'm just running this one more time, and what we'll see here is that the database definitely has a large log file, and there is also a size of around 2.7 GB for the data file. A sufficiently high number of pages, and you can see that inside the pages there is a sufficient size of fragmentation as well. And let's say that I go ahead and now shrink the database, and let me just go ahead and do that. You notice that I'm using shrink database because that's what actually happens when you do the database option auto shrink. It's not shrink file followed by the other two, it's just shrink database. And you'll see that I've got about 33%. And you'll see there's an option here that says reorganize files before releasing unused space. This may affect performance. So let's assume that, because we didn't check it, there is no fragmentation going to happen because it's not going to reorganize the files, the pages, like I mentioned before. So I'm just going to run this really quick, and just for the sake of clarity, I'm going to leave this script here as it is, and I'm just going to run it again on another window so that we can compare the numbers before and after. So the shrinking is definitely, as you can see, you're going to take some time, which is one of the reasons why you don't want it to happen automatically. When shrinking happens, there is a significant amount of I/O activity that happens on the disk because of the fact that the size of the file keeps changing. In addition to this, shrinking can actually lock the tables and cause blocking performance issues. So you have really two challenges that you're facing when you do shrink. And the first one is the fact that the I/O overhead happens significantly. And the second one is that while the operation is going on, you have blocking issues. So that's the issues that you get while shrinking. The next set of issues that you get once the shrink is complete is the fact that your indexes are highly fragmented and therefore you need to rebuild them. So the fact that you shouldn't be shrinking the database is the first thing. Now, if you have to shrink the database, you can shrink the log file because there is no impact of that, but the data files is something that you definitely don't want to shrink. So as you can see here, the shrink operation is completed. So let me just go ahead and execute this really quick, and you'll see immediately the side effect of the shrink operation. So you'll see that definitely the size of the MDF and LDF files have changed. That's good for us because it means that we have reclaimed the space. But look at the fragmentation of the clustered index at this point. And this is kind of what we're trying to avoid by preventing shrinking on the data file. Because the moment you shrink the data file, your index fragmentation shoots up to 90% typically, and all your queries start facing performance issues just because the index is fragmented, and it is fragmented. So this is what we typically see. This is the reason why we say that you shouldn't shrink your data file. Because the moment you do that, this is what you end up with in your indexes, and then you have to go ahead and rebuild them. And especially for large tables, this can be a nightmare, which we are all familiar with. So bottom line here is that, as you can see, shrinking the database is definitely bad. Shrinking the NDF and MDF files is really bad only because of the fact that it causes performance degradation on indexes and blocking. You can shrink the log file, that's good, no problems there. But at any point of time, what you need to understand is that because of the massive amount of performance issues that you can encounter as a result of shrinking, you don't want to automate it. You want to have control over it. You want to make sure it runs during your maintenance window and not randomly at some point of the day. And that is why you shouldn't be using auto shrink set to true. And I'm hoping this video makes it very clear about why shrinking in itself is bad and why setting auto shrink to true is even worse. So this is a quick video. I hope this makes it clear, even though I don't really think this is something that needs to be made clear. It's just something that we all just learn as part of the fact of being a DBA. Frankly, I wish Microsoft would just clean up these features, and every time the reason they give is the fact that it's meant for backward compatibility, but older versions are no longer supported, and I feel that it's just them being lazy to do the code cleanup and just remove unwanted options or options that they know are no longer relevant. But that's something that I've already ranted about in another video, so I'm not going to go ahead and talk about that now. Hope you've enjoyed this video, and hope you'll not be shrinking your databases unnecessarily anymore. Thank you for watching.